Okay, so for the first one here, remember we look at how the equation was put together and then we take it apart. For number 1, what's the first thing to do to take that apart? We add 2. Then we have to make sure we add 2 to the other side. So we get 5x equals 45. And then divide by 5. Perfect. X equals 9. And we could go back and put 9 in for x, and we'd see that it does work out. Gives us the same value on each side. Now for number 2, we subtract 11. Very good. So that becomes 24 equals, over here we're left with 3x, and then divide by 3. We get 8 equals x, or x equals 8. Again, you can come up here and replace x with 8. 3 times 8 is 24, plus 11 is 35. 3 and 4 is kind of where we left off yesterday. So I want to make sure we're good with those first before we move on to some new stuff. Number 3, remember we find our equal sign and we identify where the variable is, which is on the left side, but the x appears twice. Now remember, we think of this as a balanced scale. The 5x and that negative 2x are on the same side, so what are we going to do with them? We're just going to combine them, add them together to get perfect. That is a positive 5 and negative 2 makes 3x. Now we have to remember we still have that negative 4 there, equals 17. And then add 4. 3x equals 21. And then divide by 3. X equals 7. Number 4, we have a similar setup there. We have the x appears twice, but it appears once on each side. So since it's not both on the same side, we can't just push them together anymore. So what do we have to do? Okay, we get rid of one of them. The smaller one is the 3x. So we subtract 3x on both sides. Leaves us with 7 on the left side. Now on the right side, we have to take it away from the 5x. 5x minus 3x is 2x. Now we've got it reduced down so that the variable, the x, only appears once. So now we can start to solve it. And we're going to start with adding 17. Gets rid of the minus 17. 7 plus 17 is 24. So 24 equals 2x. And then we get rid of the 2. 2 multiplies the x, so we get rid of it by dividing by 2. 24 divided by 2 is 12, equals x. Any questions? Okay. So our next step is to look at equations that look like this. Looking at this one, obviously what sticks out is the parentheses. Whenever you see parentheses, it should scream at us to do something here first. Now we look at that, we have to check 2 things. Is there anything that needs to be done inside the parentheses there? No. 3x minus 7, we can't combine that or simplify that in any way. So the next question that needs to be asked, is there anything that needs to be done to the parentheses? And that is, in this case, it's being multiplied by 5. So we're going to multiply by 5. Now there are a couple of ways we could do that. Remember, one way we looked at was you write out the 3x minus 7 and you multiply by 5 this way. And that works. 5 times negative 7 is a negative 35. 5 times 3x is 15x. And we get that that multiplies out to be 15x minus 35. We can shorten that up a little bit and do it right in the problem by just distributing. So we just take that 5 and we make sure we multiply every digit, every piece that's inside that parentheses by the 5. So 5 times 3x Careful. 15x. There we go. And then 5 times, we have to make sure we remember that's a negative 7 is negative 35. That equals 25. You'll notice that is exactly what we got over here. It's just a little bit shorter way of doing it. Now, we have that 15x minus 35 equals 25. We have the variable down to appearing only once. There's nothing more that we can combine or simplify. Now we can start to solve. What do we do first? Add the 35. So 15x equals 60. And then divide by the 15. Perfect. So x equals 4. Now I get asked every now and then when we do examples like this, up here, couldn't I just divide by 5 and have 3x minus 7 equals 5? In this case, that would work, but it doesn't always work. Because we can run into problems like this, as we mentioned that, let's see, we've got, change my numbers a little bit there. Let's do 3 times 7x minus 2 minus 8 equals 70. Here, I could not just divide by 3. It's not going to work. I have to multiply out the parentheses. I have to distribute. So it's just best to get in the habit of that every time, because that will, multiplying it out will work every time. So we see the parentheses. Is there anything to do inside the parentheses? No. So we're going to times the 3. 3 times 7x, 21x, good. 3 times negative 2, negative 6. Now we can't forget we've got that negative 8 over there yet. We keep combining. We can combine what on the left side here yet? Perfect. Perfect. Negative 6 and negative 8 can be combined. So the 21x doesn't change. Negative 6 and negative 8 makes negative 14. So we write that as 21x minus 14 equals 70. Then what? We add 14. So 21x equals 84. And then divide by 21. X equals 4. Now, like any of our other problems we mentioned before, we can take x equals 4. We can go back up to that original problem. We can replace x with 4. So 3 times parentheses. Inside there, instead of 7x, we write it as 7 times 4 minus 2. Close our parentheses. Minus 8 equals 70. And let's see if this works out. Obviously, on the right side, we just have the 70. Over here, we got to start in the parentheses. 7 times 4 is 28. 28 minus 2 is 26. We can remove the parentheses now. 3 times 26 is 78. Minus 8 is 70. So we get the same value on each side of the equation. So we know that that's true. Have you guys try one? Let me give that one a shot in your notes. We start with the parentheses. Nothing to do inside of them, so we're going to multiply by the 4. 4 times 3x is 12x. 4 times 5 is 20. We still have that minus 5x there, or negative 5x. What are we going to do next? Perfect. We're going to combine the 12x and negative 5x to make 7x. Still got the plus 20 there, so 7x plus 20 equals 41. And then subtract 20. 7x equals 21. And then divide by 7. X equals 3. Just for fun, let's try something like this. Take a couple minutes in your notes and see what you can do with that. So we haven't done anything like it, but it just combines all the stuff that we have done. So see if you can put it all together and make it work, and we'll talk about it in just a minute or two. Let's see how you're doing. So in an equation like this, we can focus on one side of the equal side at a time. Now remember, there's steps that we have to do. Step one, of course, is to deal with parentheses. So let's do that first. So on the left side here, I've got parentheses to deal with. Can't do anything inside that one, so I'm going to multiply by the 4. 4 times 3x is 12x. 4 times negative 1, negative 4. Second set of parentheses, again, there's nothing to do in there. So I'm going to multiply by negative 2, we're going to treat that as. So negative 2 times 5x, negative 10x, and negative 2 times negative 7, the positive 14. Now we've done all the parentheses on the left side. Before I move over to the right side, I can actually keep going over here. The second thing we would do is we would combine or simplify everything we can on one side or the other. So on the left side here, I can combine 12x and negative 10x, which makes positive 2x. It's okay. Negative 4 and positive 14 make 10. So that's all we can combine on the left side. So now we're going to go over to the right side. We're going to deal with those parentheses first. Can't do anything inside them. So this one we're going to multiply by 3. 3 times 2x, 6x, and 3 times 1 is 3, positive 3. Next one, nothing to do inside, so we're going to multiply by the negative 2. Negative 2 times 3x, negative 6x, negative 2 times negative 8, positive 16, and we still have that minus 1 there. Now we're going to the second thing again, is to combine or simplify anything we can. We've got 6x and negative 6x makes 0x, cancels out. Now we've got 3, 16, and negative 1 make 18. That's what that adds up. 3 and 16 add up to 19, minus 1 is 18. Now the third step would be to get the variable on one side. Right now the variable disappeared on the right side, so the variable is on one side. So then our fourth step is to just solve. So looking at this, trying to solve it, what's going to be our first step? Subtracting 10. So 2x equals 8. And then divide by 3. Or divide by 3. Divide by 2. X equals 4. Any questions? That's kind of a drastic example. I wouldn't be quite that mean to you on a test quite yet, but at some point before the semester's over, we might see something similar to that. But we'll keep working our way up. Okay, we seem to be handling the integers pretty well, the negative numbers pretty well. So the next step I wanted to go to is I want to go to problem solving. That's the ultimate goal of all this stuff, is to get up to problem solving. In the classroom, that's usually word problems. And in the real world, that's critical thinking and problem solving skills. Because let's face it, life is a word problem. Your boss is not going to walk up to you ever and say, here is 3x minus 7 equals 25, find x. It doesn't work that way. But there might be a situation where the easiest way to get the answer for you is to write an equation. So we're going to start working on those word problems today. Now, just a little side note as we start these word problems. The first few examples we're going to do, since we're going to be starting simple and trying to work our way up, are going to be pretty simple to solve. In fact, they're going to be ones that you can look at them and just know how to solve them. Just combine those two numbers and we've got it. But I want you to kind of resist that urge and work with me on finding a formula, putting numbers into the formula and working with it that way. It can be a little confusing once you already know the answer of stepping back and saying, well, we still want to write an equation. But we need to get good at that skill of writing equations so we have it when we get to the more difficult problems. For example, let's talk about Pat here. Pat sells t-shirts for $12 each. How many t-shirts were sold on a day where sales totaled $408? So when we look at something like that, most of us look at that and we just know, oh, we're going to take 408 divided by 12. That'll tell us how many. But I want to step back and look at, is there a formula or a relationship that describes this? And there is. When we're talking about finding the total revenue taken in here, the formula would be the price per unit times the number sold equals total sales. We know the price is $12 each. The number sold, how many t-shirts were sold, that's what we're looking for. That's going to be our variable. We could use S or T or whatever. I'm going to put in X. X is the number of t-shirts sold. Total sales, we have that number, is 408. I knew we had to have the total sales because we already put X in for the number sold. We can only have one missing number. We don't know how to solve an equation with two missing numbers. So now we have 12 times X equals 408. We'll solve it by dividing by 12. So X equals, is that 34? So make sure we answer the question. There were 34 t-shirts sold. We might have Sam saves 1/5 of each paycheck. What was Sam's pay for the week if $86 is saved? Now again, many of you, most of you probably look at this and see, I'm just going to multiply 86 by 5. That would be the total pay. But again, let's step back and try to find a formula for this. 1/5 of each paycheck implies 1/5 times the amount of that paycheck equals the amount saved. So now we have 86 is the amount saved, so we put that in. We'll just put in P for paycheck equals 86. You can convert the 1/5 to a 20% or a 0.2 if you wanted to. In this case, that works out well because that fraction divides out exactly. If that were 1/3 or 1/7 or something like that, it wouldn't be so, yeah, you get that repeating decimal. So now to get rid of the 1/5, I'm going to divide by 1/5. So over here, I'll divide by 1/5. 86 divided by 1/5, of course, is the same as 86 times 5, which is 430. So Sam earned $430 that week. Or Sam's paycheck, I should say, was $430. Both of these problems I just did are examples of two amounts that have to equal each other. It's two different ways of writing the same amount. I'm going to go back to those symbols. It's just A equals B. The amount saved has to be equal to just 1/5 of the paycheck. There are other types of problems we run into. Like A plus B equals a total. Two things that have to add up to a total. Or we'll run into A minus B equals a difference. Two things that have to combine to make a difference. So let's look at some examples of that. Oh, let's say we've got Peyton owns 3 more pens than Alex. They have a total of 15 pens. How many does each have? Now it's real easy to look at this and say, well, there's two things that are unknown here. I have Peyton and I have Alex. And for both of them, I want to know the number of pens they have. Well, I can't have two unknown things, so I've got to figure out how to express one in terms of the other. So I look at the problem. Is one of those values calculated from the other? Or can one of them be calculated from the other with what we're showing here? We're looking at that top line. Well, let's not worry about solving it yet. Let's just look at can the number of pens that one of them owns be calculated from the number that the other owns? Yeah, if we knew Alex's, how would we find Peyton? 3 more, so just adding 3, right? So we have to ask, which one do we have to know first? Well, we would have to know Alex's first, then we would just add 3 to get Peyton's. So since we have to know Alex's first, we're going to let the number of pens Alex has be X. Once we know that, Peyton has x plus 3, just 3 more. This is a case where they have a total of 15 pens. We have two things that are adding to make a total. So we've got Peyton's, which is x plus 3, and to that we're going to add Alex, which is just x, has to add up to make a total of 15. Now to solve this, it might be easier if we think of this as 1x and 1x. We combine those to get 2x. 1x and 1x makes 2x. We still have the plus 3. That equals 15. To solve it, what are we going to do first? Subtract 3. So 2x equals 12. That's exactly what you were saying to do at the beginning, but I wanted to make sure we went through the process. So then we would divide by 2. So x equals 6. Now, again, we have to stop and make sure we go back and have answered the question. It's real easy to, once we've solved the equation, to get all excited and say, hey, we're done. But we're not. We still have to answer the question. X equals 6. Now, this is the reason why I made this little table, this little chart up here, is so I remember, what does X really represent? Well, X tells us how many Alex had. So Alex had 6 pens. Peyton was X plus 3, so that's 6 plus 3 equals 9. Peyton has 9 pens. So doing this little bit of charting up front, this little planning up front, helps us organize so that we know once we've solved the equation, we know what does that value mean and what do we have to do to find any other values. We might have Peyton has 3 times as many books as Chris. If Peyton has 18 more books than Chris, how many does each have? There's actually a couple of different relationships here. But let's go ahead and look through. We're trying to find the number of books for Peyton and for Chris. And I'm going to start off with that first line up here. Peyton has 3 times as many books as Chris. So that tells us there is a relationship between them. One of them can be calculated from the other. Which one would we have to know first? The number of books Peyton has or the number of books Chris has? Careful. Yeah, Peyton has 3 times. If we know how many Chris has, we're going to call that X. Peyton has 3 times as many. That would be 3X. So we have to know Chris's first. Then from that, we can find Peyton's by just multiplying by 3. Now, this is an example of that third type of problem, where we are subtracting to find a difference. A minus B equals a difference. Peyton minus Chris, and of course we're talking about the number of books Peyton has minus the number of books Chris has to be 18, because Peyton has 18 more. The difference between them is 18. Well, the number of books Peyton has is 3X, minus the number of books Chris has is just X. That equals 18. Once again, it might be helpful to think of that as a 1X. So we have 3X minus 1X is 2X. That equals 18. And then divide by 2. X equals 9. Now that we know X equals 9, again, we have to make sure we go back and answer the question. The question was, how many does each own? Well, X equals 9. X is the number that Chris owns. Peyton was 3X. That'll be 3 times 9. That's 27. Peyton has 27 books. Any questions? Okay. These can get more complicated. And we can start adding more levels to them. I'm just going to show you an example of that. And then we'll probably be done for the day. We're going to look at Pat again. Pat sells t-shirts for $12 each, and hats for $20 each. If Pat sells 4 times as many t-shirts as hats for a total, let's see what's that going to be. $1,020. How many of each were sold? So we have Pat. Oh, we're not Pat. We're not 2 people. We have t-shirts and we have hats. And we're looking at the number sold. Do we have a relationship between the number of t-shirts sold and the number of hats sold? Yes. 4 times as many t-shirts as hats. Which one do we have to know first? Well, if we know, to figure out the t-shirts, we have to know how many hats. If we know the hats, we call hats X, the t-shirts is 4 times X. Now, unfortunately here, we're not given the total number sold, we're given a dollar amount. So now we go back, remember that first problem we looked at, we said that the total sales was price times the number sold equals the total dollar sales. So for the t-shirts, the price is $12 times there's 4X that are sold. What is 12 times 4X? 48X. That's our dollar amount for t-shirts. For hats, the price is $20 each. There were X of them sold. 20 times X, of course, is 20X. That's our dollar amount from hats. We know that the total is 1,020. Total means we're adding them up. The dollar amount from t-shirts, which is 48X, plus our dollar amount from hats, which is 20X, has to add up to 1,020. So now what are we going to do to solve this? Careful. When we have an X appearing more than once, we've got, if they're on the same side, we combine them. Opposite sides, we get rid of them. These are on the same side. So 48 and 20, 68X. And then divide by 68. 1,020 divided by 68 is 15 look right? So x equals 15. Well, again, we have to make sure we've answered the question. We want to know how many of each were sold. Well, x is 15, so that's 15 hats. 4x would be 4 times 15. That would be 60 t-shirts. That one's a little more complex than anything I would ask you in the homework today, but again, we're going to keep building up to something like that. So now remember, there is a quiz. That is quiz number 1 that it opened yesterday, so you could have worked on it yesterday, but if you haven't finished it yet, remember it is due tonight. This is Thursday. At 11:59 p.m. If you tried it once, remember you can do the whole quiz a second time. And then there is a new homework, homework 2, which is due for Monday. Any questions? Okay. Well, I think you guys have had enough, so have a great week.